Hello, everyone. First, I am the director of the center, but my program director is really Professor Lim Yao King, and he's also the program director for this new Master of Science coursework, Semiconductor Technology and Operations. So, before I start off and talk about a personal passion of mine, which is semiconductor technology, I want to thank the industry partners, SSIA, and various partners that have been working with us to enable the launch of this new program. Okay, so to share a few things, I wanted, originally it was just a short speech. So, but instead of doing that, I just want to share why you might want to do semiconductor technology and why you want to learn about it. Okay, so I titled the talk to be "Do you know why?" and we're going to talk about some of the exciting things about semiconductor. So the first is, obviously, semiconductor technology is very unique in the sense that it's the only field which combines deep science, amazing engineering, and a very interesting business model. Okay, there's no field that's out there that combines all these aspects. So, and I think I'm going to go through a series of slides that really talk about, do you know what is semiconductor technology? Okay, so the first thing I want to start off is, what's a technology node? Anybody knows here, heard of a technology node? I'm sure you do, right? 5 nanometer, 3 nanometer stuff. Okay, so that is, today I think in the last iPhone we had the A14 chip from Apple, which is a 5 nanometer process. Okay, end of last year and this year we're going to get a 3 nanometer process. So these numbers that people say, what are these numbers about? Really, they're about size scaling. So if you look at the memory, there's always this 0.7 times the O node, 0.7 times the O node for the dimensions, and that gives us the 50% shrink in area. So Moore's law and technology nodes are all about effectively getting a 50% shrink in area for the chips, effectively double density, right? So do you know why Moore's law is dead, but not really? So why is there always two camps that says Moore's law is dead for a long time, but then a whole bunch of people still scaling chips if Moore's law is dead, right? So something that you might learn about in this course, right? For instance, since 1975, Gordon Moore of Intel has predicted that chip density is going to increase twice every 2 years. But if you look at the cost of transistors, they flattened out back in actually sometime in 28 nanometers. And today we are heading into 3, and the cost of transistors haven't come down. This is another area related that you might learn about in this course, right? About what's the value proposition of scaling when the cost per transistor is flat. Okay. Okay. So why are semiconductor fabs so expensive? Okay, so if you look at, in terms of billions of dollars in investment, like TSMC's Fab 18 is purported to be 17 to 20 billion dollars to build. The next one in Arizona in construction right now is purported to be 40 billion dollars. Now, just to put in perspective, right? One advanced US aircraft carrier is only 13 billion. So you're talking about one fab equaling to 3 aircraft carriers. Why would anybody be so crazy, right, beyond the US government to be investing in one building alone the cost of 3 aircraft carriers? Must be building something very important, right? And how do you justify the cost? So one example is, this is a not so nice picture, but this is our high NA EUV machine. This is extreme ultraviolet lithography. This one machine is just for printing chips, costs about $350 million, the size of a double-decker bus. Right? So you can see that how technology has advanced and how expensive are the infrastructure used for building something like that. Right? So again, you learn about that in the course if you do take it. And another interesting thing is cost to produce a new chip. Right, this is 65 nanometer down to 14 and 16, and today you look at the cost of making a chip from designing it, developing a software for it, validating it. It almost doubles every generation. Okay, But if you look at the bill of material, here's the one for the A17 Pro, 19 billion transistors. It's only $30 more expensive than your A16 Bionic, right? So it doubles, more than double to make the chip, but you're only seeing it $30 more on your phone. How does that business work? And why do people still selling phones if you're doing this? Amazing, right? It's mysterious, right? I mean, these are things that you learn. Why? So like I said, semiconductor has a very interesting business model, and it's coupled intimately with the technology, intimately with the engineering, and finally it comes down to the science even. Okay. So this is another one. Okay, what's the connection between Gen AI, GPUs, and silicon chips? You heard a lot about Gen AI, right? So what's the connection between chips and AI? There's an intimate connection. In fact, what made AI possible, the version that we see today, it's all due to the advancements of chips, especially more recently due to GPUs. So that's Jensen there. He's the CEO of NVIDIA, and he's even claiming that, okay, Moore's law is dead. We cannot get more performance on conventional chips. GPU will take over. But GPU is just another type of chip. Okay, right? So he's obviously selling, right? He's predicting 1,000 times more performance by 2025. But there are problems. Okay, so for instance, as more and more generative AI move towards personal devices, it's going to basically enhance the use of chips. And we're talking about shipments over 1.8 billion by 2030. Then we need faster and faster chips to run bigger and bigger AI models. And then it's going to generate heat like crazy. So AI is not green, actually. In fact, what helps AI to be green is the chip technology. Right? So you want to talk about green computing? There you go. Study semiconductors. The solution is there. It's not running more bigger AI models. That's not going to help you do anything. That's going to just eat up more energy, right? So basically, I just want to end by saying, this is the plug for the program. So if you're curious about all these questions, which I did not provide any answer here, right? Go sign up for this class. You'll learn it. You'll learn about semiconductor technology. You'll learn about operations. The program is put together by 3 departments that illustrates the point. You have material science people, you have electrical engineering, and you have industry operations and management people coming together. And so I said before, the semiconductor technology, it's a very unique field. It's a field which combines deep science, amazing engineering, and very interesting business model, right? Now, for those who are interested in research, we also have PhD and engineering doctorate programs for you to pursue, right? But other than that, I hope you have fun, and I hope more people will sign up for the program. You get to learn about this very, very interesting passion that I also hold, and learn about why is this such a powerful industry to start off with. Thank you so much. Yep.